Hey everyone, I'm Michael, and welcome to a little series that I want to call, nicknamed the Coding Bible, but I want to call it the 10 Commandments of Programming, and it's a small little series. I don't know if I'm going to actually finish it. I'm not really planning this. I'm kind of just doing it because I think it's kind of funny. But basically these are 10 mortal sins that you can commit in code, and if you do it, I will want to guillotine you. So most programmers will want to guillotine you, in fact, and so we're going to start this off with some very dastardly mistakes you could make in code, and I'm going to show you guys how not to make those mistakes, and why not to make those mistakes. So let's get started. Let's get started with commandment number 1. Thou shalt not hardcode paths. What does this mean? Well, let's walk through this little program that I wrote. So this program, what it does is it reads a file from the file system, and if that file exists, it outputs a text of that file saying this is the last time, or this is the last thing you wrote when you ran this program. And then it asks you to write some text, and it'll say it'll be saved for later and printed the next time you run this program. I'm a little bit inebriated right now, so I misspelled the word program. Let's go fix that. My bad. But actually no, it's a bug in my IDE. Okay, that's strange. Anyway, so if we write some text, winners don't drink booze, the program's going to exit, and we're going to run it again, and it's going to say last time you wrote winners don't drink booze. Alright, so this is a simple program. Now, on the surface, there's nothing wrong with it. It does exactly what it's supposed to do, and it works. It compiles, it runs, it does what the user expects it to do. And that's good. But there are several problems with this program, and there is a mortal sin in this program, and it is that we are hard-coding paths. What that means is, so when you're working with your computer and your file system, everything has a path. So let's open our file explorer, I guess, and we'll get at what I mean by this. So as you navigate your computer, you're likely going to start at this PC, and you're going to have your list of drives, and they're all going to have drive letters. Well, this is for Windows, of course, but we could, for example, navigate onto my E drive, and I'll have a bunch of folders in here. So I'll have C# Fundamentals, which is another series I would like to try eventually, teaching you guys C# from a bare-bones beginner standpoint. We have some games, we have this meme that I made in a previous video, we have a backup from a server, or from this recent server transfer of my website. I have the source code of Restitched on here and all that stuff. That's my E drive. And let's say I wanted to navigate into the games folder and see the socially distant source code. You can see that up top here, we're seeing a sort of location of where we are. We are in the E drive inside the games folder, and in there we're inside the socially distant folder. If we click on the folder next to it, we can see that the absolute path to this folder is e:/games/socially distant. This is how we get to this folder, and I know that it exists on my system because I'm looking right at it. But the problem is, I'm a human, not a computer. The operating system, is the only thing that knows that that path exists. So the problem here is, well, let's have a look at this app data variable. So let's walk through this program. The first thing that we're doing is we're declaring a app data variable, which is a string equal to c:/users/aklnthndr/appdata/roaming/mycompany/myproject. And this is a path, and the double slashes are just me escaping the backslash, because a backslash in a C-like programming language is an escape sequence. But anyway, we have this path here. And what we do is we check if the path stored in this app data directory, or in this app data variable, exists as a directory, and if not, we create it. Then what we do is we declare this hello variable, and we set it equal to app data, concatenating the file name hello.txt to the path. And then what we do is we check if that path, that hello path, exists, and if it does, we read all of its text and we output it to the console. Then we output our prompt and we ask for text from the user and we write that resulting text to the hello file. The problem here is that this is an absolute path to somewhere on my system. And the keyword is my system. See, I can take this path here and copy it, and I can navigate to it. So let's try that. Let's first start in the C drive. We're going to go users. We're going to go aklnthndr, aklnthndr. And we're going to go app data, roaming. And we're going to do my company, which you can see it exists. And we're going to do my project. And if we go there, we can see that there's the hello.txt. And if we open it in Notepad, you can see it says winners don't drink booze. So that's all well and good. The problem is that, yes, this exists on my system, but not everyone's user account is aklnthndr, and moreover, not everyone runs Windows. In fact, some people who run Windows don't actually have their C drive set with a C drive letter. We actually ran into this bug a few years ago with ShiftOS, where the game would store the save file in C:/ShiftOS. And I had a friend whose system was sort of borked, and he had his system reserved drive set up as C, and his Windows drive set up as D. And so ShiftOS would try to store the save file in his system reserved partition, which requires administrative rights to access. And so the game would crash. So that's an example of where, just because most Windows systems have a C drive, not all of them do. In fact, there's another problem here, where, again, like I said, not everyone's user account is in C:/users/aklnthndr as it's spelled right here. For example, on my system even, we can backtrack through this folder and eventually end up back in the users folder, which for some strange reason I can't actually access. But if I go into the users folder, you can see that I actually have more than aklnthndr here. I have another one that's actually spelled out properly, and this is my Microsoft account folder, and this is so that I can keep Windows activated and have Insider Program. But this is a local account. But if I were logged in to this other user here and tried to run this program, well, even though this folder exists on my system, I don't have rights to it because it doesn't belong to the Microsoft account. It belongs to the local account that I'm currently logged into, so the program will work on this account, but it won't work on the Microsoft account because they don't have rights to each other's folders. Now, of course, you can override those rights as an administrator. I can go into aklnthndr as the Microsoft account, and I can bypass the permission issues by authenticating as admin. But when we run the .NET program, we don't have that luxury unless we specifically enable it by either right-clicking the exe file and running as administrator, or enabling it in an app manifest. But moreover, that's if the directory even exists. If the directory doesn't exist, well, we're going to run into other issues, where suddenly now your program is going to create an account, or an account home folder, in a directory that it doesn't have access to. Because generally speaking, programs shouldn't be able to access the C:/users folder. No, that's Windows only. Only Windows should be able to create folders in here. So you're going to crash. And then there's another issue. A few years ago, Microsoft started working on this thing called .NET Core. And .NET Core, what it allows you to do is it allows you to run these C# programs that are written, traditionally for Windows on macOS and Linux. The problem is that macOS and Linux don't use drive letters or backslashes in their paths. They use forward slashes and they use mount points. Let's SSH into my Linux server here and give you an example of what I mean. This server runs Ubuntu, specifically Ubuntu server, and you can see that I'm logged in my home directory. If I print my current working directory with pwd, you can see that I'm in the home/Richie folder. Now you can, so this is the home folder, this is the equivalent of users on Windows, and in fact on macOS it's also called users. But we're in the /home folder, and if we go up another level, we are in the root folder, and this is where everything is stored. And in Linux, you can't go above the root folder. There are no drive letters. There's only the root and mount points. And mount points are generally stored in the MNT folder. For example, I have cruise volume here, which is my Nextcloud storage. So you can see that there are some differences to how paths work on Linux versus how they work on Windows. So there are several issues that we're going to run into when we use hard-coded paths like this. For one, we might not have a C drive, we might not be running Windows, or we might be running a weird Windows install that doesn't have a C drive that we have access to. We might be running a different operating system that uses a different character to separate paths. And we might be running Windows, and we might have a C drive, and everything is going to be fine, but we might not have access to the users directory, and the aklnthndr user doesn't exist. Or it might exist, but we're logged into a different user account, and we don't have administrative rights to go ahead and write that folder. So how do we solve this? Because, well, the problem that I'm trying to solve with this variable is I want to know where the roaming users application data folder is, which is generally where you should store your app data. The way you do that in C# is, well, for one, get rid of the mortal sin of the hard-coded path. Now, what you're going to go ahead and do is you're going to use the environment.getFolderPath method. And this is going to take an environment.specialFolder enum, which gives us a whole load of different system and user folders that we have access to that are specified in the environment that we're running on. For example, we have the cookies folder, and we have the desktop folder. We also have the application data folder. And if we look at the summary for this, you can see that it represents the path for the application data for the current roaming user on a network. Now, don't let that confuse you. That is that's some weird Windows domain stuff, but really it means app data/roaming. So, application data. Now, common application data is for all users. So if you have a system program that stores data for every user, you might not want to use the roaming user's application data. And the common application data will map to the C:/program data folder, or I believe user/local on Linux. I don't know what it is on Mac, but anyway. The last one that we have here is local application data, which maps to app data/local, which if you are on a Windows domain and you don't want the data syncing across workstations, this is where you can store that data. It'll only sync, or it'll only be existent on that workstation. So that might be useful to you, but in most cases, when you want user-specific data, you can use roaming. And it's actually probably a better idea to. You might actually want that data to sync. Anyway, we're going to use application data. And that gets us the platform-specific application data folder. And from there, we can add my company, my project. But we're still sinning here. We're still hard-coding paths. Though we have a relative path, we still have a hard-coded relative path, and that's not great. We have two of them, actually, but we'll solve one at a time. There are two issues with this. For one, well, this path could change at some point. And we might change the name of our company or the name of our program, so we might want to actually, store those variables separately somewhere in the assembly info or something, but we'll discount that for now. The other problem that we really immediately need to worry about, this is the actual sin, is that we are still hard-coding these backslashes. If we're on Linux, this is going to break. If we're on Mac, this is going to break. The way we get around that is by using the path.combine method. If we surround this variable declaration with path.combine, this takes a dynamic parameter list of strings. It takes a param's paths. So a dynamic parameter list of paths. And what this means is we no longer need to concatenate these strings. We can replace that plus with a comma. So this will attach these two paths together. But in fact, we can get rid of this backslash here, and it will automatically insert the correct path separator between the commas. And then we can remove this one, because it's a dynamic parameter list, by putting a comma between these two strings. And now we end up with the exact same path as before. However, we have not hard-coded it. This will be platform agnostic. And it will in fact get the correct path for this user because of the environment call that we made. The next thing that we're doing right here is the exact same thing. We're concatenating a relative path to something, and that's not something you should do. We can use path.combine here as well. So this will take the app data folder and combine hello.txt to it, adding the correct separator. This will be platform agnostic, and it won't be hard-coded. So now, we can run our program and see how it works. Now, there is a slight issue. Actually, no, there isn't. I just didn't see it properly. Sorry about that. Anyway, we can see that the last time we ran this program, we typed in winners don't drink booze. So it did find the file, and that's great. However, this time if we write Richie, it's going to write Richie to the file, and it's going to work exactly the way it did before, except now this program can run on Linux, Windows, and macOS, and even on weird installs of Windows where the user is not on the C drive. So yeah, that is really great. We have turned a really crappy sinful program into one that's actually sane and doesn't need to be crucified. So, commandment number 1, do not hard-code paths, because it makes it incredibly difficult to deal with multi-platform support and, weird systems. Anyway, as always, I've been Michael, hope you learned something, and I will see you guys in the next video. Thanks for watching.